Good morning. Welcome to Geometry class. From this week, our lesson is from Chapter 12, Lesson 1. It's about tangent lines. This is from your textbook pages 762 to 768. Before we start, I want you to prepare the following: your geometry book, your pen, and your copybook. Our objectives: to use the relationship between a radius and a tangent. Next, to use tangents to solve real-life problems such as finding the distance between the centers of. Using the radius-tangent relationship. What is a tangent? A tangent is a line in the plane of a circle that intersects the circle in exactly one point. For example, line J. What is a point of tangency? This is the point where a circle and a tangent intersect, and that is point B. Next, ray BA is a tangent ray, and line segment BA is a tangent segment.
What is a tangent line to a circle? Well, a tangent line to a circle is a line that has a special relationship with a circle. To help us see this relationship, let's go ahead and do a bit of exploring with lines and circles. So say we take this circle here and we draw a line through it. So here, we'll have a line going through this circle. Now notice, this line intersects our circle at 2 points. At this point right here, and at this point right here. Neat. Now, what if we take another circle and another line? Except this time, instead of having the line intersect the circle, we just draw it alongside it. Just like this. So this line will never intersect the circle. There are no points of intersection. Well, what if we take another case with this circle, and we draw a line that just sort of goes right next to the circle. It only hits it at one point. So here we only have one point of intersection. This point right here. This line sort of skims right across that circle and only hits it at this one point. When we have a case like this line is called a tangent line to that circle. So, a tangent line to a circle is a line that intersects that circle at only one point. Here, these two lines are not tangent lines to the circle because this line intersects that circle 2 times. It can only intersect the circle once. Here, this line doesn't intersect the circle at all, so there are even no points of intersection. Here, this is a tangent line to this circle. It goes along next to the circle and only intersects it at one point. This point where the tangent line intersects that circle is called the point of tangency. Now, when we have a tangent line to the circle, that tangent line has a special relationship with the radius. If we take a radius for this circle, so from the center point, we draw a line out to the edge of the circle. And here, let's make that line connect up with that point of tangency. So here we have a radius. It measures r. When we have a tangent line to the circle, the tangent line and the radius that goes from that center point to the point of tangency form perpendicular lines. So here, when those two lines intersect one another, we get right angle here and another right angle here. So now we know, a tangent line to a circle is a line that crosses a circle at only one point.
In this problem, you will find the measures of angles formed by tangents to a circle. Segment ML and segment MN are tangent to circle O. What is the value of x? Your answer choices are A, 58, B, 63, C, 90, and D, 117. What kind of angle is formed by a radius? and a tangent. The angle formed is a right angle, so the measure is 90. Since segment ML and segment MN are tangent to circle O, angle L and angle N are right angles. L, M, N, O is a quadrilateral, so the sum of the angle measures is 360 degrees. The angles of a quadrilateral sum to 360 degrees. Substitute the known angle measures. Now simplify. Finally, solve for the measure of angle M. So the value of x is 63. The correct answer is B.
From Theorem 12-1, we have the given figure. We have tangent, which is line segment AB. If a line is a tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency. So line segment AB is perpendicular to OP. Okay, another example. Find the value of x. We have the given 132 degrees from angle O. So what is the measurement of angle S? Since angle T and angle E has 90 degrees, we need to substitute these values to get the value of x. So 90 plus 132 plus 90 plus x is equal to 360 degrees. Why did we use 360 degrees? Because we have quadrilateral DOES, and the sum of all the measurement of this quadrilateral is 360 degrees. So 90 plus 132 plus 90 is 312. So 312 plus x is equal to 360 degrees. Now, simplify. The value of x is equal to 360 minus 312 is 48. So it means the measurement angle S is 48 degrees. From the other practice, assume lines are tangent. Find the value of x. Number 1. We have the given 60 degrees. And we need to find the value of x. We all know that the two angles are perpendicular. It forms perpendicular line. So, 60 plus 90 plus 90 plus x is equal to 360 degrees. What is the answer? Yes, the answer is 120 degrees. How about the other example? Okay. We have 30 degrees. Why? Because we have 60 plus x is equal to 180. Since this is triangle and the sum of all triangle is 180, we will use the sum of all the measure of these angles. So 60 plus x is equal to 180. So x is equal to 180 minus 60 is 30 degrees. Next, from the last given, we have 38 degrees. And we need to find the value of x. Since the other angle is 90 degrees, we will use the equation 38 plus 90 plus x is equal to 180. Again, this is a triangle. Now, x is equal to 180 minus 38 plus 90 is 52 degrees. From theorem 12-2, if a line in the plane of a circle is perpendicular to the radius at its endpoint on the circle, then the line is tangent to the circle. It means line segment AB is perpendicular to line segment OE. So line segment AB is tangent to circle O. Got it 1. Line segment AB is tangent to circle O. What is the value of x? I'll give you 10 seconds to answer this question. Timer starts now.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Time's up. The answer is x equals 52. Since line segment ED is tangent to circle O, line segment ED is perpendicular to radius line segment OD by theorem 12-1. So 38 plus the measure of angle D plus the measure of angle E is equal to 108 degrees by triangle angle sum theorem. So 38 plus 90 plus x is equal to 180. And 38 plus 90 is 128. Simplify. 128 plus x is equal to 180. So by subtracting 128 from each side, x is equal to 52. So the measurement of angle E is 52 degrees.
In this problem, you will use a tangent to find a distance. The CN Tower in Toronto, Canada has an observation deck 447 meters above ground level. About how far is it from the observation deck to the horizon? Earth's radius is about 6,400 kilometers.
Okay, step 1, make a sketch. The length, 447 meters, is about 4,500 kilometers. What is our plan? How does knowing Earth's radius help? So the radius forms of a right angle with the tangent line from the observation deck to the horizon. So you can use two radii, the tower's height and the tangent, to form a right triangle. Step 2. Step 2. Use the Pythagorean theorem. CT, or line segment CT squared, is equal to line segment TE squared plus CE squared. This is the same thing with C squared is equal to A squared plus B squared. Next, substitute. So we have 6,400 plus 0.45 raised to 2. So we need to add line segment CT, and that is equal to DE squared, which is unknown, plus 6,400 squared. Simplify. What is 6,400 plus 0.45? That is 6,400.45. Then we will raise to the power of 2 is equal to DE squared plus 6,400 squared. Now, what is 6,400.45 squared? It will be 40,965,760.2025, and that is equal to DE squared plus 40,960,000. So DE squared is equal to 5,760.2025. So what is the value of line segment TE? That is approximately 76 kilometers. So the distance from the CN Tower to the horizon is about 76 kilometers. Topic number 2. Question: what is the distance to the horizon that a person can see on a clear day from an airplane 2 miles above Earth? Earth's radius is about 4,000 miles. I'll give you a chance to answer this question. Timer starts now.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Time's up. What is your answer? The answer is D is approximately 127 miles. With the use of the Pythagorean theorem and the fact that the radius of Earth is 4,000 miles, we will use 4,000 plus 2 squared is equal to 4,000 squared plus D squared. Simplify will be 16,004 is equal to 16 million plus D squared. To get the variable D squared, we will subtract these two numbers. So it will be D squared is equal to 16,004. To remove the exponent 2, we will put radical sign on both sides. So D is equal to square root of 16,004. What is the square root of 16,004? The answer is 127. So the distance from the airplane to the horizon is about 127 miles.